Hello and welcome everyone to today's webinar on modern AI forecasting workflows, wherein we are going to discuss about what are the modern techniques, like modern ways of doing forecasting. Thank you everyone for joining us. Whether you work in a data science, analytics, or a business strategy domain, you will leave with a practical knowledge to apply advanced forecasting architectures like the one we will explore today. Our goal here today will be a breakdown in end-to-end production grade AI forecasting pipeline. We'll review three reading model families and to understand each workflow's block so you can confidently architect or improve your own solutions. Here, our agenda will be laying the foundation, data preparation, data cleaning, and feature engineering part. And then we'll deep dive into our three forecasting pipelines, which is NBERTs, NHITS, and TFT, which is neural-based expansion analysis for interpretable time series. And NHITS, which means neural hierarchical interpolations for time series forecasting. And TFT, which is a temporal fusion transformers. So we'll go through all these three forecasting pipelines and then we'll select the model building pipeline, and based upon that, we can just train our model and fine tune it according to our requirement. So let's begin our session here. So here we are having the architecture. So you can see here, firstly, when we will start our any like data collection, data preparation, we will get our data from a client. Once we'll get the data from the client, we will start preparing or gathering the anomalies in the data, gather all relevant time series or exogenous variables, clean up the anomalies and inconsistencies to lay a strong foundation within the data set. Then we'll come to a data cleaning part, wherein we will have outliers, inconsistencies, or normalize or scaling in the data. Once all these data cleaning part is done, we will switch to a missing value handling, wherein we will have a techniques ranging from basic imputation to advanced model-based filling. After that, we will have a feature engineering. Here, we will expertise, shine, and lag the features, rolling it, averages, event indicators, all these things we will do here. And then after this, we will just split our data into training, testing, and validation likewise. Okay, we are going to train our data on a training data set and we are going to evaluate our data on a test data set. So here, then after doing all this data preparation, data cleaning, all these part, after then we will have a model building part or model selection part. At the model selection, the pipeline will split into three categories. Like I have told you, we are going to understand these three pipelines today. We are going to understand about NBERTs, NHITS, and TFT. So here in the NBERTs, it is a deep stake-based approach for generic and interpretable forecasting work, wherein we will have our NHITS, which is a hierarchical interpolations for multi-resolution signal extraction based. And then we will have a temporal fusion transformer, which is a hybrid model blending attention, variable selection, as well as deep temporal patterns. Okay. So here, when we are coming to when we are coming to the NBERTs, we are going to understand about the model initialization. So NBERT will start with the parameter initialization for both backcast. Along with that, we will have a forecast blocks. Okay, so this is our backstack as well as a block stack constructions. So what will happen in the block stack constructions? We will have a multiple blocks which will be stacked for iterative refinements. Each blocks deal with 10 or seasonality learning separately. After this, we will have a backcast forecast generation, wherein we will have each block predicts both the target forecasted value, along with that it will reconstruct the inputs, which is also called as backcast. Okay, block cast is something else and back cast is something else. Okay, so here it will do what? It will do both backcast along with backcast. It will do a forecast blocks. Okay, so here we are extracting two things we are predicting here. First, we are targeting a target variable will going to do a forecasting part, and then we will reconstruct the input, which will be a backcast and which will be used to prevent the overfitting or boost the interpretability in the model. So this is what is NBERT is. Here we are having two domains and it will do two tasks here. Okay. Then what is the key strength of this particular NBERT? It will excels with pure univariate series wherein domain independent learning is needed. Is very much important. So here as what will be the real world example for this particular type of NBERTs. So predicting the energy load demand for utilities or forecasting on historical patterns rather than domain specific signals. Okay, so these are some of the examples, real world examples related to NBERT and where we can use this. Okay, we can use it only for the pure univariate series. Then when it comes to N hits, this is your N hit. Now within your N hit, we'll prepare multi-resolution hierarchical stack. Okay, so instead of two stack, we are having multiple hierarchical stack. Hierarchical interpolation stack data is analyzed at multiple frequencies like short, medium, long, and individually models also. Okay, so here in the hierarchical interpolation stack, what will happen? It will take a multiple frequencies and analyze whether it is short, medium, or long. Okay, the data is analyzed at multiple frequencies. Once the data has analyzed, we will go to a multi-resolution processing. Within the multi-resolution processing, we will have outputs which are aggregated to produce a holistic forecasting. Okay, we will form a aggregate values. From that, we will have a forecasting work. So this is what your N hits is. Okay, we will first check and analyze our data with multiple frequency values, and then we will do what? We will output the aggregated values, and then we will forecast that particular values in multi-resolution processing. Okay, so here, where we can use this, when to use this, it is great for when there is a very noisy or multi-scale data. For example, web traffic or sale mixing, holidays and promotions. All these times we can use this particular type of N-hits forecasting model. Okay, if we are capturing both the fine spike and the long-term drifts, which is critical. So N-hits can outperform a simpler model. It will perform like a simple model. Then at the end, we are having this TFT model, which is this. Okay, this is your TFT model. So what is there in this TFT model? So this is the largest workflow in the architecture of Temporal Fusion Transformer. Here we will initialize our model. So in the initialization part, we will have our initial parameter setup. Once the parameter is set up, what we will do, we will have our variation selection network or variable selection network, wherein unlike older models, TFT will actively pick which input matters most at each time point. It is crucial for multivariate forecasting. Okay, it will only pick one input at one time. Okay, at one time point. Okay, at 1 second, for example, at 1 second, it is picking one input. Like this. So then, once we have selected it and form it into multivariate forecasting point, we will have a temporal fusion decoder, which will encode the historical context into a latent representation. Okay, like an embedding, we are having a numerical representation of a textual format, and then we will form a context vector, or either we can say that we will form a latent representation of that particular inputs. Once we will have here, since this architecture is also called as Temporal Fusion Transformer. So here we will have a transformer architecture, which will also have an attention mechanism. Okay, here in the attention mechanism, we are having a self-attention surfaces which will keep the steps. We will have our attention scores. We will weight with the attention matrix, and then we will form our context vector from here. Once the model training is done, like we will train with both the time series as well as exogenous signals. We will train with both the datas. And then we will do what? We will have our hyperparameter tuning, wherein we can add multiple like drop out, drop connect, multiple other things, multi-head attention mechanisms. We can apply a block counts. All these things we can apply in the hyperparameter tuning part. Once we have done with the hyperparameter tuning, we will check for validations. Once our model is trained, we are used a hyperparameter tuning, we will use our epochs, and then we will have our training accuracy. Along with that, we will built-in loop for a cross validations and hyperparameter search for validation dataset. If for both the case, if it is satisfactory, we'll continue to inference the fast forecasting. Okay. Or otherwise, we will exit. If not satisfactory, we will again going to fine tune this particular model. Again, we will do retraining, all these things, hyperparameter checking, all these things we will. Okay, like learning rate, all these things. Learning rate, there will be multiple other things will be there. Okay, then after once our model is trained and it is good, it is performing good for validation data set also. Then we will have our model evaluation technique. Within our model evaluation, we will have multiple things like if our output variable is numeric, we can have MAE, then we can have RMSE, we can have MEPE, all these things. And we can also check our model using plots or regional assessments, all these things also we can check our model. Then we will have our interpretability analysis. So TFT will explain which variables and time points drove a prediction essential for business trust. Now, TFT best use, where we can use this. Okay, where we can use this particular model. So this is highly dynamic market. Okay, we can use it in retail, finance, supply chain. We can use it in needing transparency, and we can use it for multivariant analysis also. Also, like when we will do a comparison of all these, like all these three models. So both will have both the models, all three models in terms of model results will have both numerically and visually output. Okay, so we will select a best model from all of these three. Now we will do a hands-on and we will apply all these three pipeline in one case, and we will see which model is giving us the better accuracy. So whatever the model will give us the better accuracy, we'll compare them. We will use the best model out of them, and we can deploy the model on a production side as well as on a server side. Okay, so let's go for coding hands-on. So here you can see, I'm importing all the required libraries over here. I have imported required libraries. I have installed required libraries. Okay. Once I've installed all these libraries, I have used this data set. Which data set I have used is, I have used this data set called as Advanced Retail Sales Dataset, which is a monthly economic time series dataset, which is published by US Census Bureau, and it is maintained by Federal Reserve Bank of St. Louis. It provides early estimates of US retail and food services. It forms sales, offering snapshots of customer spending trends before the final data is available. So this dataset belongs to our retail, food and sales department. Okay. So here you can see we have imported this data set. Once we have imported this data set, you can see this is the data set. This is a time series data set we have imported. Okay. And this is a publicly available data. You can also search advanced retail data set. You can also. Okay. So we are making this data into a scalar format, and then we are using this TFT. For TFT, we are using this particular month and year as an value columns. Then at the end, we are defining our model here, wherein we are using NBERT, NHITS, and TFT, all three models. You can see here, we are having input chunk length, output chunk length, and we are having a generic architecture, which is true. We are taking the architecture of this NBERT itself. And here also we can see, and the most important thing here we are adding is a hyperparameter. When I'm saying that if the model accuracy is not good, we will change this hyperparameter. Okay, we will continuously tune this hyperparameter and retain the model again and again. So this is our pipeline of this particular three model. Then after training our model, we are going to evaluate our model based upon ME. Since you can see this data is all about numeric. There is no categorical variables are here. Okay, so we have taken output as an ME, RMSE, MEP, and we are going to forecast this particular model. Okay, so once we have trained this and we have seen the accuracy, let me show you. You can see the visualization here. Okay, so you can see here for year 2025 till year 2025, it was there, our data was there. But you can see here, it is forecasting results by using NBERTs, NHITS, and TFT model. It is giving the output of this for year 2026, what will be the output, or whether the sales are going to high, whether this food and sales will going to high, or it will not going to be, like it will be on a profit side or it will be on a loss side. It is like that. So it is a retail sale versus this is your year or date, we can say. And this is actually forecasting this model particularly. This is your actual value up till here, and it is only published till here. So it is going to like by using this particular model, we have forecasted that by using NBERT, it is forecasting whether it is going to go high or down, likewise. So particularly this three model will going to give you a result accordingly. Okay, so this is the model, guys. I hope you have enjoyed today's session. So we have understood about all these three models. We have understood the use cases related to this three model, how to train these three models. All these things we have understood today. Okay, and we have taken the hands-on on all this. Okay, so this is our inquiry number. If you want to contact us, okay, our salesperson will going to call you after this. Okay. Okay, guys, thank you for joining. We'll meet you in the with the new topic on the next lecture. Thank you once again.